Welcome to this presentation on enhancing Retrieval Augmented Generation (RAG) systems with hybrid approaches. We'll explore how integrating knowledge graphs and advanced retrieval techniques can significantly improve the contextual accuracy and efficiency of RAG systems. By the end of this presentation, you'll understand the key benefits and best practices for implementing these enhancements. You'll be equipped to kickstart your hybrid RAG deep dive. Let's get started. Traditional Retrieval Augmented Generation (RAG) systems often depend solely on one retrieval method, which can limit the depth and context of information retrieved. Vector search is a prominent approach that's frequently used in RAG systems and builds a solid foundation for semantic search. With vector search, text is transformed into a numerical representation, an embedding vector that captures its meaning. More text and more embedding vectors form a vector space that opens up the possibility to apply mathematical procedures. Search can be implemented by using distance metrics. Search queries are embedded, text information is embedded, and the nearer an embedded search query is to an embedded piece of information, the more relevant it is. A top 10 list of the nearest information is your retrieval result. While vectors are typically retrieved via similarity, you may miss some context that's not immediately apparent. For example, a name of an author to a passage in a book. That's where knowledge graphs are beneficial. They offer a structured way to represent relationships between data points, enhancing contextual understanding. By integrating knowledge graphs with vector retrieval, we create hybrid RAG systems that leverage the strengths of both approaches. For more details, please refer to Asya Khan's post on Letria's blog. Especially her real-world examples and different approaches to hybrid RAG systems are an interesting read. By combining retrieval-based methods with generative models, hybrid RAG systems enhance contextual accuracy. This integration allows the system to access relevant information from vast datasets, ensuring the generated text is factually accurate and coherent. By retrieving pertinent documents before generating responses, these systems provide context-specific details that standalone generative models might overlook. As you may already know, evaluation is key. Experiments indicate that hybrid RAG outperforms traditional methods in both retrieval accuracy and answer generation, demonstrating its potential for broader applications beyond finance. For further insights, please refer to the paper Hybrid RAG: Integrating Knowledge Graphs and Vector Retrieval Augmented Generation for Efficient Information Extraction, available on arXiv. Effective data structuring is essential for optimizing RAG systems. Besides efficient management of large datasets, hierarchical organization supports the retrieval of the most relevant piece of information. Ashish Pawar suggests in his post on Data Science Central the organization of data into tiers, like topic, subtopic, details, to help the model retrieve the most relevant layer based on the query. He also mentions metadata and tags as ways to point the model to what's relevant and to boost retrieval speed. The interesting thing is, most vector databases come with a metadata field, but in my experience, it's an often overlooked feature. We mentioned embeddings and how they play a key role by representing data points in high-dimensional space, enhancing search accuracy. Ashish Pawar finishes his post with an interesting challenge, leading us back to hybrid approaches to RAG. The over-reliance on embeddings. He says further, while embeddings are great, they're not perfect. A balance of keyword and embedding-based retrieval often yields better results, especially when handling varied queries. Another hybrid retrieval technique is the combination of BM25 and FISS, enhancing context awareness in RAG pipelines. BM25 ranks documents based on term frequency and inverse document frequency, while FISS specializes in high-dimensional vector search. This integration leverages the strengths of both models, improving retrieval accuracy and context awareness. For more information, please refer to Arooj's article Implementing Hybrid Retrieval BM25 plus FIS in RAG on Kitika. Hybrid RAG systems enhance complex reasoning capabilities by combining multiple retrieval-based methods with generative models. This was evident during the Meta Comprehensive RAG (CRAG) KDD Cup 2024 competition. A work called A Hybrid RAG System with Comprehensive Enhancement on Complex Reasoning got third place in retrieval summarization and won the prize for 5 out of 7 question types in knowledge graph and web retrieval. The paper suggests optimizations such as attribute predictor, LLM knowledge extractor, knowledge graph module, reasoning module, among others. Besides diving into the paper, taking a scroll through the winner's announcement is interesting as well. Hybrid data structures represent the future of Retrieval Augmented Generation, RAG, by combining their strengths into a powerful retrieval system. We saw enhanced contextual relevance, retrieval accuracy and speed, as well as improved reasoning capabilities in combination with generative models. However, it all comes with a higher data management need. I suggest start small and evaluate, but not as small as it can possibly get, as switching data storage falls under the category heavy lifting in evaluation cycles. As we look ahead, hybrid data structures will enable more innovative applications, making RAG systems more versatile and effective in handling complex queries and diverse data types.